Okay, take 2 of the sign chart. Sorry, I did not like how it came out last time, so I am redoing it. Okay, so we've got X. I like to do F double prime, F prime, and F. Oh, I made it pretty tall. See, there we go. Okay, so now we've got, remember, 3, 4, and 2. 2, 3, and 4. Remember, 3 was just for the first derivative. So 2 and 4 was also for the second derivative. Also kind of why I like to go F double prime, F prime, and F. So that here, whenever I'm working on everything, oops, maybe if I could wipe that out. Let's scribble that. Scribble, 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 scribble. It just helps me remember that 3 is for F prime, 2 and 4 for F double prime. So I'm going to work first derivative first, which means I'm going to do the 3. So that was a 0 for F prime. Okay, so 0 for F prime. So I'm going to choose 0. Remember, this is for the first derivative, so we're going to plug it into the first derivative. Okay, so if I plug in 0 here, we get a negative. So negative, 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 which means F is decreasing. Then over here, if I do 10, right, because remember 3 is just for the first derivative. Popping 10 into the first derivative, we're going to get a positive. Because remember, it's called a sign chart, not a number chart. We don't actually care what the number value is. We only care about what the output is, the sign, right? The sign. So if F prime is positive, that means F is increasing. Now we're going to move on to our second derivative numbers, which was the 2 and 4. So let's see. Suppose I go with 0 again. So if I go with 0, that's 0, 0, a negative. So negative, negative, negative. So if F prime is negative, what does that mean about F? Concave up or down? Down. Good. Concave down. So if I go with 2, any number between 2 and 4, right? So you could use 3 if you wanted to. Okay, so let's try 3. So if I do 3, I'm going to let my calculator help me. Hit clear. Okay, so 4, I'm going to store 3 in for X. Okay, so now whenever I have X, I'm going to have a 3. All right, so I'm just going to punch this in. Negative 2x squared plus 12x minus 16. All right, and that's a positive 2. Okay, so again, I don't care the fact that it was 2. I only care that it was positive. So if F prime is positive, what does that mean about F? Concave up. Now I'm going to use 10 again over here. So we're going to toss in 10, right? Oh, actually I probably should have done it down here. If I toss 10 into this version, right? So tossing 3 into here works a lot better, okay? Because you'll get a negative times a negative times a positive. You see that? So you get the positive. So if I throw in 10, I get a negative times a positive. So that gives me a negative output. So now, if F double prime is negative, the concavity is down. What's really nice about this is that your first and second derivative, they should reinforce each other. Because what extrema do we have happening at 3? Perfect, a min. And doesn't it make sense that if I have a min, I'm at the bottom of a bowl? Perfect, good. All right. Okay, so now we're going to graph. So, let's see. Y-axis, x-axis, 1, 2, 3, 4. So I've got 2, 3, 4, maybe 5 for good measure. Here, if I have f of 3, I've already found that out. That's 0, okay, just by plugging 3 into the original equation. Okay, plugging 3 into the original equation. Let's see, because that would be 9 minus 18 plus 10. That would be the natural log of 1. And what's the natural log, or any log of 1? 0. Perfect. Good. That's one of those, like, you kind of have to remember your college algebra situations. Remember, log base A of 1, always 0. So the natural log of 1 is 0. Keep that in mind. So if I know I've got a min at 3, here's my min at 3. And then what's happening at 2 and 4? We're changing concavity. So what do we have at 2 and 4? Inflection points. Inflection points. So here we had a min, but at 2 and 4 we have inflection points. So what I'm going to do is just kind of give myself my bowl, and then here I'm going to kind of just give it wings. Because again, we have to be decreasing and then increasing. And then f prime has to go from concave down to concave up to concave down again. Okay, this is something that does just kind of come with practice. But lucky for you, in 5.4, we're not going to do anything this challenging. Okay. But in any case, let's see. That concludes just this example. Okay. Super long example. I think it spanned over 3 different videos. I'm so sorry. I will try to think through that next time. But in any case, that is the page for example 5. Okay. So moving right along then. Got 2 more pages before 5.3 is finished. These next 2 I think are super fun. I hope you agree. We'll find out. Again, feel free to email me just to say, like, no, not super fun, crazy lady. But again, I hope you like it. Okay, so a graph can change concavity over a discontinuity, which is not an inflection point, so it's not a point at all. Remember, so that's when I was discussing earlier around the vertical asymptotes. Okay, so... Sorry, I'm just getting my side notes prepared so that I make sure to keep on track. So I have let f of x equal 1 over x. That's this picture here. Determine the intervals where f is concave up and where f is concave down. Again, you won't have the picture, okay? So mathematically, you'll need to know how to do that, and that's the whole point of this exercise. So, concavity is that first derivative or second derivative? A second derivative. So our step-by-step approach is 1. Find f prime of x. 2. Find the second derivative. 3. We're going to set the second derivative equal to 0. And then 4. Solve. Right? And then sign chart, so on and so forth. All right. So... f of x is equal to x to the negative first. So f prime of x is equal to negative x to the negative 2. So f double prime of x is equal to positive 2x to the negative third, which is also just 2 over x cubed. Now, if we set this equal to 0, we recognize that we have a critical value at x equaling 0. But again, it's not technically a value at all. So we notice that we have a value in the denominator giving us 0 at x equaling 0. Okay, so that is this point right here, the vertical asymptote. Okay, so here, if we do our sign chart, here's 0, we've got x, f double prime and f. Let's see if I choose -1. Okay, well, -1 times -1 times -1 is negative. So we are indeed concave down. If I choose +1, 1 times 1 times 1 is positive, so we've got concave up. So mathematically and pictorially, we can say without any hesitation that we are concave down from -infinity to 0 and concave up from 0 to infinity. Perfect. So again, this example is just to emphasize that you can change concavity at points of discontinuity, or most of the times, to be honest, they're vertical asymptotes. So now example 7, this is kind of one of my favorite questions. It's more of a reasoning question of like, explain to me why e to the x is always concave up. Okay, because the picture and just knowing e to the x, yeah, it's always concave up. That's definition of an exponent, right? But here I'm going to show you mathematically why that is. So on a test, you may have like the different bubbles to choose from that explain mathematically why that is. So again, 1, find y prime, which is g prime of x, right? Sorry, got a little lazy there. And then find y double prime, which is g double prime. I'm going to switch over to y prime for emphasis, y double prime for emphasis. Set that equal to 0 for solve, right? Okay, well, remember, e to the x is its own derivative. So finding the first and second derivative, pretty easy. But now, e to the x is always greater than 0 by definition. Remember, for all exponentials, make sure I'm still on video here, a to the x has a domain of has a domain of -infinity to infinity and a range of 0 to infinity. Right? So that's what I mean when I say by definition, right? All exponentials have a range of 0 to infinity, not inclusive of 0. So to show that g of x equaling e to the x is always concave up, well, it's because first off, e to the x is its own derivative, right? And by definition, all exponents are going to have a positive output, okay? If it's a base exponent, right? If you just have the parent function, that's a key word there, just the parent function. No translations occurred. Otherwise, it's fair game. So here, we are always concave up, okay? Because f double prime is always positive. There we go. So you would explain this by saying the second derivative of e to the x is also always positive. Cool. Fun, yeah? Hopefully. Maybe? No, maybe not. That's all right. Okay. All right, last problem. Point of diminishing returns. And here, this is emphasizing, again, the correlation that f double prime connection is saying the behavior of f prime. Okay, so I'll write that at the top. All right, recall that y double prime describes the behavior of y prime. Also, then tells us where y prime has a max or a min, or plural, maxes, mins. All right, so point of diminishing returns. Increased spending on advertising will result in increased sales. When sales increase, they increase at a, when sales increase, they increase at an increasing rate for a while. But eventually it will increase at a decreasing rate. Okay, so let me read all that back to you. Increased spending on advertising will result in increased sales. At least we hope. When sales increase, they increase at an increasing rate for a while, but eventually will increase at a decreasing rate. Meaning that like our acquisition of people probably is not, we're not getting as many people a day. So what this is trying to say, that assume a company started to advertise on Instagram. Okay. Well, the first, month, I'm just picking a random time. The first month, maybe they have 3 people sign up, and then 5 people, and then 10 people, and then 20 people. And then after a while, after the consumer has seen that ad over and over and over again, new people will just start to flip right by it, right? They're not going to pay attention. But there are some people who will finally be like, I've seen this thing 100 times. Maybe I should finally sign up for it. So maybe they stopped at 20 people a day was their highest. And then it was like 19 people added, and then 15 people added, and then 12 people added. So they're still getting people to add to their company, right? They're still getting people to purchase their things, but the rate of people adding has decreased. Do y'all see that? Again, if you have a question, write it down, shoot me an email. Okay, so the value of X, where the rate of change of sales changes from increasing to decreasing, is called the point of diminishing returns. Okay, so in business calculus, if y'all have friends taking business calculus, or if you change your major to business calculus, you may have to take that class to replace this one. But I don't know about that. I could be lying to you. But anyways, business cal, this is a huge question. But I really like it a lot because it emphasizes the relationship from y prime to y double prime to y prime. That's why it's in here. Okay, so i.e. point where the rate of change is a local max. So since we're talking about the rate of change for the derivative, that's a y double prime question. Okay, because we're talking about the behavior of y prime, the behavior of the derivative. So here's the actual question. A company estimates that sales will increase from 1,500 stereos to n of x equaling 4x cubed minus 0.2x to the fourth plus 1,500, where where x is between 0 and 14 inclusive. Where n is the number of stereos and x is thousands of dollars spent on ads. Find the point of diminishing returns. What is the max rate of change in sales?